Hello everyone, welcome back to another video. Today we are going to discuss another room on TryHackMe and it's named as SQL Injection. It's a continuity of the introduction to the web hacking module on TryHackMe and it's a room on the junior penetration tester pathway on the TryHackMe as well. So in this room we are gonna discuss about an SQL injection, the vulnerability here, and how we detect an SQL injection, how we exploit an SQL injection. On the back end, what is being done to exploit the SQL injection, and how we attackers insert the malicious queries into the database that is being tricked to give us some sensitive information as well. So without further, let's start with the task number one. So SQL injection, as clear by the name, is an injection, which means it's intended to be malicious, and SQL stands for structured query language. So as we know that most of the modern web applications generally utilize a database structure on the back end of it, and the database generally holds the purpose to store the user information, and it stores the data related to the web application, and it could include the user information and content and everything. And in order to make the web application dynamic, the web application has to interact with the database in real time. So to fulfill this, hypertext transfer protocol request arrive from the user, and the web application's backend will issue the queries to the database to build the response as such. So here the attacking methodology comes into play. Generally, when we send a request here, it could be given some malicious input, and this could be tricked into the database into giving us sensitive information. So SQL injection generally refers to the injection given to the database of MySQL, and at the most common of this is when a web application communicates with a database using input from a user that hasn't been properly validated. There runs the potential of an attacker being able to steal, delete, or alter private customer data, and also the attack on the web application authentication methods to private or other customer areas. Basically, getting some sensitive information is the goal of an attacker by tricking the database into doing unintended purposes. There are generally many ways to accomplish this attack, and to generally make the SQL injection to work, the attacker must first generally inject the SQL code, and then then get to know about what is the web application logic here involved, and then according to that we need to give out our particular injections or payloads. SQL is generally the most generally abused vulnerability, and it is the most oldest among the all of the web application vulnerabilities, and it can also be used for the most damaging vulnerability among all of the other in the open source web application security project top 10 OWASP in short. Answer out our first question, which is what does the SQL stands for? So it stands for structured query language. And yeah, with that we completed our task number one, and now let's dive into task number two. So now we need to know what exactly is a database even. So if you are not familiar with databases, then it's not possible that you can exploit this vulnerability or any kind of other injection vulnerabilities as well. You need to know how the database is handling all the user requests in order to abuse it. So what is a database? A database is generally a way of electronically storing collections of data in an organized manner. So it involves the user's data, so it is a lot sensitive, and we as an attacker aim to exploit this by some injections and tricking the uh, database into doing some unintended purposes. So how we are gonna abuse this, we are gonna discuss. So first of all, a database is controlled by a DBMS, which is the short form of database management system. And database management system fall into generally two uh, categories. Here we can it can be relational and non-relational. So we are going to discuss the relational databases in this room, and some common ones you will come across are MySQL, Microsoft SQL Server, and PostgreSQL and SQLite. So we are gonna discuss the difference between this as well, the what is the difference between relational and non-relational databases. So but first let's just understand what are the important terms we need to learn. So within a DBMS you can generally have multiple databases, and each DBMS has its own set of related data in a particular database of a DBMS. So let's understand this with an example. For example, you have a database called shop, and within this database you want to store the information about the products available to purchase and the users who have signed up for your online shop. And according to this, you would be having multiple databases. For example, you would be having one for having users data, one for having products, one for orders have been received, one for orders being delivered. So you will likely store it in the separate uh, tables, something called tables in an organized manner, because you need to sort it out categorically, what needs to be placed in the orders, what needs to be purchased in the shop, and what needs to be purchased in the further subcategories of a particular main category. So these tables are identified with a username for each one, and you can see the structure. Okay, so we have a structure over here. So it shows a most common way that the business might use to store up the data. So here we have a particular database server, and that database server is divided into three categories. First is the shop, staff, and accounts. Okay, so in the shop one we have different tables. We are sorting it out furthermore categorically into the table users, products, and orders. Okay, then we have staff, which contains the users information and the audits, and then we have the third database, which contains the accounts of the customers, orders, and payroll. Okay, so I hope you get the basic idea that DBMS is basically something that controls all the databases, and DBMS is database management system, and it is further divided into multiple databases, where each database is further divided into a category called tables to categorically sort it out. We generally need to visualize a table as such that it contains columns and rows, where the vertical lines are called as columns and the horizontal lines are called as rows in the table. And here every column and row is containing different kind of data. So here if we look into this table, then we generally see that there is a column, there are three columns, and there are generally four rows over here. And on the top of it, the first row contains three columns, where the first column has been given the ID, generally the field it's called, and the second row and the second column and the first row is given the key value of username, and the third row of the third column of the first row is given the key value of the password. And here on the downside of it, every particular information related to that key pair is being stored in that particular row or in that particular column, sorry, which is given the particular value. So I hope you get it that it's a more categorical way and the most of the easy way we sort out the things in a database as such. So here we can generally store different types of data. For example, the ID value would be having some numerical digits, and the username would be having couple of strings, couple of letters, which are called strings in the database, and it could be used for storing dates or even location as such. Yeah, and the data type is being also the key value, what data needs to be stored over here. So that's the particular main purpose of using such database, and it sorts out the data more categorically. And if we visualize it one more time, we have a database management server which is given the which has been used to manage particular databases, and we have three further databases which are further sorted out into different tables, and each table is sorted out into columns and categories where each column is given a particular key value, and under that particular column would be given out the particular data in different rows. And that's the more overview, that's the overview of the database. And yeah, now we need to understand what's the difference between a relational database and a non-relational database. So a relational database generally stores information in tables. Here we can see that it's a relational database, and it's more sorted out, the database generally in columns and in rows. To specify, we need use columns and define the data being stored, and rows actually uh, it actually stores the data. The tables will often contain a column that has a unique ID, which is given the primary key. Here we can see that it's ID on the first column, and on the second it's username, and on the third it's password. And it can be used for the other tables to reference it, and generally can be used to create a relationship between different tables, and which is why it is called a relational database. Relational means it can be used for creating couple of relations among interconnected fields. So while on other databases which are non-relational, as cleared by the name as well, that it doesn't generally have a relation between each of these values, and they don't have any sort of tables or rows to store the data. A specific database layout doesn't needs to be considered for this data to be stored, and giving more flexibility over a relational database but not being sorted out categorically. Everything comes with a disadvantage. So yeah, here we will be discussing non-relational databases, and yeah, we will be discussing relational databases. And one primary example of a relational database is SQL, and exploiting up an SQL database, MySQL database, is called SQL injection, whereas some non-relational databases generally include MongoDB and NoSQL, and no, they generally can be exploited as well, but it's not the main focus of our today. We are gonna learn about SQL injections, and SQL injections is being inserted into MySQL databases, or anything that is related to relational databases can be abused. So we have our first question. What is the short form or acronym for the software that controls a database? It's called DBMIS, DBMS Database Management Service, which it stands for. Then we have another question, that what is the name of the grid-like structure? Grid-like structure meaning it would be table having different columns and rows to store out the data, where each column is given a particular primary key or a unique ID, we say. So now we jump onto the task number 3. We covered out what are databases generally in this task number 2. Now we need to discuss what is an SQL at the most core level. So SQL is a structured query language. It is a feature-rich language, and it is used for querying databases to fulfill the needs of the particular user using of the web application. And the simplest of the command which we will cover is generally using the SQL to get out the data, and we can update, insert and delete data using these. And somewhat databases have their own syntax, and it slightly changes to how the things work. So all of these examples are related are generally based on the MySQL database. So you need to generally learn what are these, how to use these to query out the particular information in a database stored on the database. And after learning the lesson, you will be easily able to generate the syntax of these SQL syntax and get out the information as well as you will be able to maliciously inject this to a username field or any particular field being passed, and generally get out the sensitive data out of the database of a database using MySQL as a relational database. If it is using, then you can ultimately try to inject an SQL and see if there are any filters or not, and you can retrieve any information or not as a result of that particular query. So first of all, we need to understand how we can use an SQL to get out the database. We can use the select command to which will be our first query of the discussion, and it's used to retrieve the data from the database. Here we can see that the select, and here we have a strike sign over here where the first word select tells the database wants to select some data, okay, as clear by the name as well. And the static tells the database we want to receive back all the columns from the table, and the column generally contains the key values we discussed previously, and it's a unique ID that is holding out a particular purpose. So we from this select all from user is basically means that we select all the columns for the table. And for example, let's try to understand it with an example. The table may contain 3 columns. Let's visualize up our previous shop database having a particular table of users information, username and a password, where each username is having a password. And here we can see that we have let's say 3 columns. So when we say that select all from the users, it's gonna generally show out the particular columns or the unique IDs being stored. So it tells the database we want to retrieve data from the table name users. Finally, the semicolon at the end tells the database that this is the end of the query. So users is generally a table being stored on a particular database, and so it tells the database to give out all the columns being stored on this table, and as a result of this we will get the names of the columns. So we will get the names like ID, username and password. And so then continuing this, the next query of us will be to get out what this particular column contains. So we will generally give out this particular query on the SQL to select username password from user. We generally don't want to get out the ID, but the matter of interest for us will be username and password. And once we have the unique identifier by just giving out this query select all columns from users, we will get the columns, and now we will try to get out the what the username and password will be containing. So we will give out select username and password from users, and now it's gonna be selected. And then we will be the first query will be to that returns all the columns using the selector, and then limit 1 forces the database to, now we want to generally get out the user information out of it. So we will select that limit 1 means that give out the first user information, and select all from users where username admin, so it's gonna filter out for the particular username named as admin. And on when this will return the rows where the username is equal to admin, it's returning where the column is being referred to an admin, and it returned everything where the username is admin. So here when we which is equal to admin, this will only return the rows where the user's name is equal to admin. Okay, so this query basically will return where the username on the particular key value pair, the column is having the value of admin in the row. And on the next query, we have this not equal to, where we don't have an admin, just return it as such. So the username John and Martin doesn't have the value, the key value in the username of admin. So when we give out not equal to admin, it gives us not admin users, non-admin users, which are John and Martin respectively. Then we have another query over here: select all from user where username is admin or username is John, give out. And so this is gonna give the where the on the particular row of a particular column, the key value, we select the username here, select all, or we say to the database that you need to select all from the users table, and you need to we are mentioning you the particular key value or the key ID of a particular column, and we say that username on this particular key value having any of the data in this particular row of the column is admin, then return it to as such. Or query means that, and or means that any if any of this is true, just give us to both. So if there's a username admin, give it admin as well, and if there is John as well, then give us John as well. So, and then we have and means that if the username is, if both of these conditions are true, then just give out that particular information. So this will here in this query, it will say to the database to select all the data from the users table and select all the columns from the users table, and where the username is having a particular username key value is having a particular row value equal to admin, and as well the second condition, which is password is equals to this, where we have the password of the admin, then return it as such. Remember that in the and condition, most of these conditions should be true, while on the or any of these conditions should be true, that either of it, if the admin is true or the username is John, give us two, both, give us both if they both exist, or give us either one of them. So then we have another thing: select all from user where username like ampersand means that it's a wildcard which is used to represent a character by percentage sign, that anything starting with the A, give it with as such. And here we will see that the admin is starting with the A. Any rows with the username beginning with the letter A, and then we have any rows username with the beginning of the letter N. So this returns any rows with the username ending with the letter N. Okay, so here we have the particular username. Okay, so here is a difference. We have a percent, the percentage sign means to begin with the A and then filter out any data, any row data on a particular key value. Primary key we say as such. So A and then filter out, it should begin with the character A, and at the end means that it should end with the character N. And the modulus sign generally comes first in here in this case, while on the first case the A and then there was a percentage sign, and that's the primary difference. One represents the beginning while the other represents the ending. So this will return any rows ending with the letter N of a particular column we selected out. And that's all the queries. And we have one more. For example, I'm going to zoom it out so it's more readable, sorry. Select for all from user where username like m or modulus sign or percentage sign, whatever you call it, mi percent. It's going to return any row with the username containing mi within them, and anything within the modulus signs will be considered by the database to give out and to filter out anything. And if there is a character at the starting before the modulus sign, the database is going to consider that for filtering out anything with the letter A is gonna give out by the database. Whereas if the modular sign is coming first, and then the particular character, then anything ending on the particular characters or characters, then it's going to be considered by the database. Then we have the union. The union statement combines the result of two or more select statements to retrieve data from either single or multiple tables. The rules to this query are that union statement must retrieve the same number of columns in each select statement. So union, as clear by the name, has said that it combines the two or more select statements to retrieve data from either single or generally multiple tables. And the rules to this query are that union statements must retrieve the same number of columns in each select statement. You can't just query out multiple columns or the particular primary key value pairs. We say primary key values, we say, that are given, or unique ID being given to the column, and the columns have to be of similar data type as well, and the column order has to be same as well. So let's start. It's quite confusing, so let's start with an example or an analogy as well. So a company wants to create a list of addresses for all the customers and suppliers to post a new catalog, and we have one table called customers within the following contents. Having the following contents, we have the ID, for the ID unique value on the first column, we have the name unique value on the second column, we have the address unique value on the third column, we have the city value on the fourth column, and the postcode value on the fifth column. Okay, where each of these column rows contains different values, and the data is different. The ID contains the numbers, the name contains strings, the address contains strings, and the city contains strings as well. The postcode contains numbers too. So, and another called suppliers within the following content. So we have different tables. One is called table, and another is called ID, company addresses, city, and postal code. So we are gonna use the following SQL statement. We can gather from the results from the two tables and put them into one result set. Okay. So here select name, address, city, postal code from the customers table, as well as it says to union select company, address, city, postal code from supplier. So what the union is saying is to take out the name, addresses, city, postal code, particular key values, columns from the customers table. We have this customers table over here if you don't know, and these are all the unique values containing different data in their respective rows. And the union means that select this as well as another, do this job first and also do this particular job that you need to. This is the second table over here if you don't know that it's a suppliers table, and it says that okay, do this as well, and according along with this particular request, I want one more thing. Union means I want one more thing along with you. You need to get out this particular company addresses, city, postcode, unique values of the columns, which contains respective data in the rows as well from the suppliers table, and I want the result of all of this. And as a result of all this, we get what we know, relatively generally what we say, that a combined format of both this data. For example, we got name, addresses, city, postal code uh, from the first table, and on the second table we got a suppliers table as well. So as a result, the customers and the suppliers were combined, and the most important thing here is that they both contain the same format. What I mean by this is the postal code contains postal codes. It does not contain numbers, only numbers. It contains a number, although it doesn't contain only numbers which are IDs. So if you do that, the union query will fail as a result of that. You need to know about the data type of the particular unique ID column having respective data in their rows. And that's the purpose of union. if you are having multiple data having similar data types, it can be combined into one format and give out as a result of this query. Then we have what is called the insert statement, which tells the database that we wish to create a new row of the data into the table, and you need some particular privileges to do that as well. So into users tells the database which table we wish to insert data into. Username password provides a column which we are providing with, and then values having the particular bob and the password. Okay, so let's take this insert into users. Insert into users, which tells that we wish to insert the data rather than not taking it away. And then the users is the key value of the unique ID, we say, of the particular column, and the username and the password is what we say, the values. Okay, sorry, I mistook it. The users is the table, and the username and the password are the unique values over here. And here we have the values being given. The values generally contains the values we need to specify for this particular column, for both of these particular unique IDs columns. So Bob and password 123 are the values we need to give into for all of these users, and as a result of this, into our existing column over into our existing this table over here, what's this table? Okay, so this was existing table over here. Martin admin Bob password 123 was inserted as a result of this query over here at the end, where so insert means to insert the particular users, as simple as that, and we need to specify out the columns unique ID along with the values we need to give out to insert, and we need to have privileges in order to do this as well. So then we have the update statement, which tells the database we wish to update one or more rows of the data within a table. You specify the table you wish to update, saying update modulus table name modulus set. Okay, so update, as clear by the name, it tells the database we need to update the data, the existing data, and then you give out the particular value. Okay, so here is a simple query being a simple statement, we say. These are all statements. Okay, statement means to give out a particular statement to the database to fulfill this task. And yeah, so update the users table. Okay, update the users tables and set the username root to password 123, where username is equals to admin. So what is this doing is this, we have this admin on the second, and here it first we supplied out the existing data on the existing table. We say okay, here we have set out this particular username to root and the password to the 123, where the existing username was admin. So set first we specify out that okay, we need this data, and what we need to replace is the username, existing username admin, and it is pretty clear, as I say. And then we have the final statement, which is the delete statement, and it is also clear by the name that it means to delete out something on the database, and it wishes to we can delete one or more rows of data of a particular unique ID in a column. To delete, a simple statement is to delete from users where username is equals to Martin. So it said okay, delete, take the table users, and on this particular user where the username is equals to Martin, delete out this particular rows and delete out its particular every other columns and every other data as well. So you can specify precisely which data to delete using the where clause and the number of rows deleted using the limit clause, and it can be limited as such. But when no where clause was being used, all the data was deleted as a result of all this. And one more thing you would notice is this semicolon being supplied on every statement. This is a statement terminator that specifies out the end of our query statement, and we need to specify it in an SQL because it is what called case sensitive language. And what it means by this, that it doesn't ignore the semicolons, which is generally ignored if you have ever coded in the Python. So you need to give out a semicolon, otherwise it would result into an error. So let's jump into the questions which we are being asked out. So here, what SQL statement is used to retrieve data? So we discussed previously that the SQL statements we used to retrieve data was select, and select was being used to get out the data along with the union statements as well. So what SQL clause can be used to retrieve data from the multiple tables? It's union, and remember that the data that it's gonna retrieve should be of the similar data type in order to succeed out with our request. Now we have the third question, what SQL statement is used to add data, and that would be insert. We discussed as well that insert SQL statement is going to insert out and data into an existing database, storing different data in rows of a particular unique ID in a column. And with that, we completed our task number, if I remember, 3. We completed out our task number 3. And now it's time for the task number 4. So what is an SQL injection? Here we need to understand that an SQL injection in a web application means to turn the basic SQL queries into doing the database unintended purposes. So generally, something when we access on a web application, it goes into a request to the database for the user to give out the particular data. And for example, let's take a login form as an example. So here, if we got a particular login form on TryHackMe, or we are trying to log in into TryHackMe, then we will be having we will be supplying some of our credentials, and we for example specified out our credentials that we are alpha, or we have the password as well alpha. So now on the back end, it's going to verify that we do have this particular values on the database on the TryHackMe backend, and when it is being done as such, we can give out as our username being a close syntax to this particular query, and injecting our malicious input into that particular field where we are specifying out our username or password, and tricking the database into doing the unintended purpose, into giving out a sensitive information on the database, hosting the users and the passwords on the TryHackMe or whatever is being attacked as such. So what it does look like. So here we have a nice example of TryHackMe as well, that we for example have been stored, there is a website storing blogs. Okay, so website.tryhackme having the ID of 1. From the article you can see that the blog entry selected comes from the ID parameter in the query string. The web application needs to retrieve the article from the database, and when it's a MySQL is being used for storing the data, we can maliciously execute an SQL statement. It would look something like select all from the blog, and we need to understand that we need to make some basic assumptions over here. We need to guess out the particular table. If not, if we want to show out the tables, but first we need to generally understand what is being stored on the database as such. But for example, for the table is blog, and we say that select all from the blog where ID is equals to 1 and private is equals to 0, and limit the 1. This is the original web application request being sent to the SQL database to retrieve out the data for the blog having the ID of 1, and to display out the results to the user and fulfilling the request of the user. So we have learned previously that this would be the basic work of an SQL statement, and we could give out the ID of 1. We could give out the ID of 2 as well over here, and we would get out the block having the ID of 2 as a result. The semicolon here specifies the end of the SQL statement, and the two dashes cause everything afterwards to be terminated as a comment. So what this means is you are in fact just running the query. Select all from the block where id is equals to 2, and everything should be treated as a comment, and it should be ignored. That's the main purpose. The double slash, the double dashes we say, means to say to the server that what we are saying doesn't matter. What we say to the previously, that's the end of the statement. So it mentions what generally it looks like. Select all from the block where id is equals to 2, and that would be the end of the statement, and you don't need to have to paste further data out as such. And this is the basic vulnerability that is being inserted. The semicolon in the URL signifies the end of the statement. It is the statement terminator, and here the double slash means that everything afterwards would be treated as comments, meaning that and private is equals to 0 and limit 1 would be bypassed as such, and you are just running out the query. Select all from log where id is equals to 2, which will return the article with an id of 2, and whether it is set to public or not, we will get an output out of it. So this was just one example of an SQL injection vulnerability, and it's called an in-band SQL injection. There are further SQL injections are categorically sorted out into three types: in-band SQL injection, a blind SQL injection, and out of and SQL injection. Okay, so we are going to discuss that as well, but first let's just answer out the questions over here. Which character signifies the end of an SQL query? It's going to be a semicolon, and remember that it needs to be specified out at every SQL statement we're making. And with that, we completed out our task number 4 as well. Now let's just jump into task number 5. So there we have a particular classification of an SQL injection. Yeah, that's the right word. So we have an instance as well. What I'm looking at, it would be to demonstrate out this injection. Anyways, let's read out what is an in-band SQL injection. It is the easiest type to detect and exploit. In-band SQL injection just refers to the same method of communication being used to exploit the vulnerability and also receive the results. For example, discovering an SQL injection vulnerability on a website page and then being able to extract data from the database to the same page. That is an example of in-band SQL injection. So what we have learned till now is an in-band SQL injection. The previous injection we inserted into the blog of the website is called an SQL injection. We just communicated out friendly with the server, and we detected by inserting some malicious commands, and as a result of it we were able to exploit it. And it's the this just refers the same method of communication being used to exploit the vulnerability and also receive the results. And we also noticed that we made the database to ignore out the else statements by giving out a semicolon. Then we have an error-based SQL injection, which this type of SQL injection is generally useful for easily obtaining the infrastructure about the database structure, and the error messages from the database are promptly directed onto our browser screen, and it is generally more useful for the enumeration stage when we are trying to exploit as a penetration tester or as a bug bounty hunter, that whether it is generally using a MySQL database, what tables are being used, and further in the enumeration state error reveals a lot about the database itself. Then we have the union-based SQL injection. This type of SQL injection utilizes the SQL union operation alongside a select statement to return additional results to the page. This method is the most common way of extracting large amounts of data via an SQL injection. Union, we also discussed that it takes multiple key values, key unique identifiers of the column having particular data, and taking out everything on that particular column rows, and it takes multiple of the multiple users, multiple tables in an input to do so. Like it would take from the customers table everything on the every column on the customers table, every column on a suppliers table, and would give you a combined result, and thus it could be used for extracting really large amounts of data. So now we have a practical over here given us to the TryHackMe. So I've opened up this practical demo website, and level 1 of the practice lab contains a mock browser and a website featuring a blog with different articles which can be accessed by changing the ID number in the query string. Okay, so we have particular ID value in the URL field. The key to discovering error-based SQL injection is to break the code's SQL query by trying some different character until an error is produced. So first of all, we need to make an error in order to generally make or abuse the SQL database. So the most common way of using or producing the error messages is by using an apostrophe or quotation marks. So first let's try giving out apostrophe. Okay, so we get an syntax error as a response, which confirms that the MySQL is being used as a database server, and which is essentially vulnerable to SQL since it led to an error. So the key to discovering error-based SQL injection is to break the code's SQL query by trying certain characters, and here we were able to get a successful error-based SQL injection, by the way. So we tried giving out the apostrophe. After, you will return an SQL error informing you an error in your syntax. The fact that you received this error contains the existence of an SQL injection, and that's what we are gonna abuse. So we can exploit this vulnerability and use the error messages to learn more about the database structure. So the first thing we need to do is to return data to the browser without displaying an error message first. So first we will try the union operator, so we can receive an extra result if we choose setting the ID parameter to 1. Okay, so we are gonna give the value of 1 and we are gonna select the first column. Okay, so we didn't get anything. The statement should produce an error message informing that the union select statement had a different number of columns than the original select query. So let's try again, but another column, 1 select union 1 2. We are gonna give another, okay, one other column 1 2. The use selector statement have different number of columns, so we have another error, which means that our injections is working but the number of columns are generally not correct. We don't have 2 columns over here. So the article displayed because it takes the first return result somewhere in the website source and shows that, and that basically confirms us the in-band SQL injection as well, since we are getting directly in the browser the results of the SQL. So this can simply, to get around, we need the first query to produce. Okay, so we missed this. Let's try another column over here, 1 2 3, and boom, we got. Let's first give a, okay, so we confirmed us that 3 columns do exist by giving this malicious SQL injection payload. Since it didn't give us the error, so it means that there are 3 columns. each having the value 1, 2, and 3. So we can then start using these return values to retrieve more useful information. First, we will get the database name by using the database function over here. Let's try to get the database function. Okay, so the database is SQLi1, and our next query will be to get a list of tables that are available in this particular database. For this, we are going to use this particular query, which is going to select 1 and 2, and it's going to give out the name of the tables as a result of it. So we don't need to understand on the back end what is being done, but for now let's just inject this code and let's see what do we get. So we get two columns, names, article, and staff users as a result of this SQL injection payload. We selected first and second column, and then we used some functions to filter out our results. So there are a couple of things you need to learn. First, the group concat, which gets the specified column, in our case, which is first and second, from multiple return rows and puts it into Spring by different columns. And the next thing is the information schema database. Every user of the database has access to this, and it contains information about the database. And the tables and the user which has access to. In this particular query, we are listing all the users in the SQLi1 database, which is staff and which is article and staff users. So as the first level aims to discover the master and password, okay, we need to get out the Martin's password. So we are gonna get out what is in the table name of staff users. So let's inject this malicious payload and let's see what do we get. This is similar to the, however, the information we want to retrieve has changed from table name to column name. Okay. The table are querying in the information schema database has changed from tables to columns. Okay. And we are searching for any rows where the table name column has a value of staff users. But it wasn't generally successful. The query results provides 3 columns. I guess I didn't copy it. Where okay, so yeah, it wasn't copied, sorry. So let's give this, and okay, so we get 3 columns unique IDs in the table of staff users in a particular database having the name of SQLi1. That's the main overview we are doing over here. So we get 3 unique column IDs, ID, username, and password, and then we are gonna get the particular rows data, and we are gonna select first and second, and then filtering out, and then inserting a line break, and from staff users get all the sensitive data. That's what this payload is gonna do. And we get the Martin's password as a result of this query or the payload. And we are going to check, and the BR tag over here is used for the line break, and we successfully did in-band SQL injection. And yeah, then we move to the task number 6, which is blind SQL authentication bypass. So unlike in generally the in-band SQL injection, where we can see the results, the blind as clear by the name, we generally don't see a successful result over here as we got in the in-band SQL injection directly on the screen. Blind SQL injection is when we get error to no feedback to confirm whether our injected queries were in fact successful or not. And this is because the error messages have been disabled as a security feature on the back end of the particular company or in the enterprise environment, and the injection still works regardless, but we couldn't confirm if it works or not. So it might surprise you that all we need is a little bit of general feedback to enumerate a whole database. So authentication bypass can be done using a blind SQL injection, and one of the most straightforward blind blind SQL injection is generally authentication bypass, which is such as in the login forms. We aren't interested in retrieving data from the database. We just need to get bypassed by the login, which is storing the user's data in the database. So login forms, practical level 2 of the SQL injection examples shows this exact example. We see in the box labeled SQL query that the query to the database is the following: select all from users where username table as users is the table over here, and username is the unique identifier having everything that is starting that is with the username, and the password, everything with the password is being given to us as such. So the username and password values are taken from the login field. The initial values in the SQL query will be blank as these fields are currently empty. To make this into query, we will return this or, and 1 is equals to 1. So what is this going to do is on the back end, when we give out a particular username and a password, for example, if I say admin and admin, here we can see that the SQL query select all from the users, and where the username is equals to admin and password is equals to admin. The username is generally the column unique identifier where it's going to select all the rows in that particular unique identifier column to look for the admin value and then compare it with the password column unique identifier particular row as well, and it limits to 1 to only look down for this particular one entry. And so if we could execute this, or 1 is equals to 1, if we just give us the admin, and if we give us this or 1 is equals to 1, then we can see that our query becomes as such that select all from usernames. And if I just give us the username as blank and select all from user where username is blank and password is equal to 1 is equals to 1, password is also blank and 1 is equals to 1, and it ends the statement with a comment as well. So here we are using an OR statement. OR means that either of the one conditions are true, and then on the back end it would be validated without a username as such. This will cause the query to return always true, since 1 is equals to 1 is always true. And here we can see that when we give us for example, wait, I'm gonna use the admin and admin again. So here the username is admin and password is equals to admin. This is a general SQL query, but when we just don't give us the username and we just give us one apostrophe, meaning it's the end of the SQL query over here, meaning the password is empty, the password is generally blank, and then we give us an operator or operator which is always true in the case of 1 is equals to 1, and then we say to ignore all the comments afterwards, and it should be treated as comments afterwards and just give us the result of it as such or authenticate us as such. And if we log in, and boom, we bypassed the authentication using a simple SQL based injection. And this is the most common of the blind SQL injection, where we don't know whether our SQL injection payload was successful or not, but the result of the authentication would validate it as such. And we need to make certain assumptions, but like for example, here we need it's not necessary that the table name would be users and the username field would be username and password field would be password, and either of it there is no errors to verify that the MySQL database is used. But if we just give us a blind shot, like it's clear from the name as well, we might get authenticated as well. So we are going to submit this flag SQL injection, So this was the flag, I guess. Okay, so this is the flag. Sorry, that was the first flag. So I hope that was clear. The blind SQL injection, which we use to bypass the authentication, and how it works on the backend. Now we are gonna use the blind SQL injection, Boolean based. So here we have another login form. So Boolean based SQL injection refers to the response where we receive from our injection attempts and which would be true or false. Boolean means that either of the two condition states. These two condition states can be on or off. In other words, it means binary. The Boolean values which are 1 or 0. And either of it can be true. The output generally confirms that our SQL injection payload was either successful or not on the first inspection. You may generally feel this limited response can't provide much information. Still, with just two responses, it's possible to enumerate a whole database structure and the contents. So let's dive into the practical to get out what it feels like. So http website.tryhackme check user having a user name equal to admin, and the browser body contains taken true. Okay, so the API endpoint replicates a common feature found on many sign-up forms, which checks whether a username has already been registered to prompt to the user to choose a different username. And if it's false, then it would be meaning that the user can register it, and if it's true, then user should generally use a different name. Because the taken value is said to be true, we can assume the username admin is already registered. We can confirm this by changing the usernames in the MOX address bar from admin to admin123, and upon pressing enter you will see that the value taken has now checked and now been checked to false. So taken, yeah, okay, so we can see that taken false. Okay, and the SQL query being processed on the backend, we can see that select all from users where username is equals to we say the username being supplied, which is admin123, and limit 1 to just give us the one particular entry, and the only input we have control over is the username in the query string, and we will have to use this to perform our SQL injection. Keeping the username, our ultimate goal would be, I guess, to give us the value of false so we can register as an admin. It's pretty clear as well. Keeping the username as 123, we can start appending to this try and make the database confirm true things, changing the state of the taken fields from false to true. Okay, we need to exploit it. Link in the previous level. Our first task is to establish the number of columns in the users. We need to get out what the columns are. So I'm gonna give this. So taken is equals to false, changing the username value to the following. The web application has responded with the taken as false, which we can confirm this is an incorrect value of columns. So keeping on, so there's no one column, and we can execute 1 2 3, and on the 3 it would return true, which means that it's having 3 columns. Yeah, taken is equals to true. We can confirm that the answer is 3 columns by setting the username to the below value. Note we have number of columns has been established. We can work the enumeration of the database using the database function we used previously, and then using the like operator to try and find results that will return a database true status. So our main goal is to get true out of it, not false. So okay, so this is true. We get a successful response because in this like operator we have just we have the value of modulus, which will match anything as its wildcard value, anything as such. If we change the wildcard operator to a%, you will see. Okay, so let's try, because this is being passed as a variable, we can consider it, and it's being matched on the backend, so it was returned true previously. and we can cycle through all the characters, numbers and characters such as, and ultimately get the value. So we can, for example, if a b c, we can iterate through it, and there are useful tools we can use. What is this strategy called? It's called brute force, and on s it would return true, so meaning the first name is generally true. So s is the initial character, and we can try proceeding it with sq, and sq and so would return false, meaning sq is gonna be true. Okay, so we can then sqli. Okay, and then we will brute force till we get out the database name, which will be sql3, and this will be true, meaning the sql3 database name is true. We have established the database name. We can now enumerate the table names using a similar method by utilizing the information schema database. Try setting the username to the following value. Okay, let's see what do we have over here. So this is false. Let's switch it to the B. The initial letter is not B. The initial letter is false, so that means that it is not, the A is not the initial character. We are gonna iterate the username. Initial first character username table. We are looking for a column having something like user. So when we give us the u, we get our taken is equals to true, and we are gonna look at it using different tools and automation approach until we come up with a successful one, unique identifier, which is users. And admin123 select where table schema SQL free and table name is equals to users. We will be now lastly we need to enumerate the column table in the user so we can properly search for it using the login credentials. I'm gonna just use this, and we are gonna give this in the username field. And let's just, okay, so we get a taken is equals to true, which ultimately means that we just need to get the columns table and columns. Here we are gonna give the admin123 union select 123 from information schema columns where table is SQL3 and the table name is users and column name like starting with the A. So it's really huge. So let's run this, and it's given the name false, and we are going to iterate through letters, numbers and character until we find a valid match. As you are looking for multiple results, you will have to add this for your payload each time you find a new column. To avoid disturbing the same one, for example, once we found the column named ID, you will append that your original payload. So we are gonna give us, once we find out, we are gonna just ask for everything other than the column having the unique identifier of ID. Repeating this process 3, and this will give us a value of true. Repeating this process 3 times will enable you to discover the columns ID, usernames and passwords, which you can now use to query the users table for login credentials. First, you will need to discover a valid username, which you can use via this. You are just gonna query to the database using the free existing columns rows for a unique identifier. For particularly on the particular rows of the unique identifier for username beginning with the A, and if any of it like A, D, M, I, N was successful, then you are gonna adjust where username is equals to admin and password. You are gonna iterate through each password numbers until you get a validate. You are validate means the taken is equals to true. Then as a result of all this, you will get you will get the username and the password as well. So cycling through all the characters, numbers, and possible combinations is the main goal on of the boolean based SQL injection till you get a taken true entity as well. So you will discover the password is 3845. So we are gonna log in with 3845, and we exploited up the boolean based SQL injection, and it was quite interesting to see this. Now we have the time based SQL injection. We are gonna move to the task number 8. A time-based SQL injection is very similar to the above Boolean-based one. Is that the same requests are sent, but there is no visual indicator of your queries being wrong or right this time, and you are generally gonna use time as a parameter for identifying if your queries are right or not. Your indicator of a correct query is based on the time the query takes to compute. The time delay is introduced using the built-in functions such as sleep alongside the union statements, and if it's taking more than usual time, then it's mean that it's a time-based SQL injection, as well as that. So when trying to establish the number of columns, you might use the sleep 5. So if you get a response after 5 minutes or 5 seconds, then it confirms as the time-based SQL injection. So on this time-based SQL injection, we are going to use the sleep function to sleep between the response time, and as a result validate the database name. We are going to first look for what the database name is by iterating over commonly used characters. For the U, we are don't gonna get okay, so I just specified the referrer for 2 times, and we get a response time of 0.01 seconds, meaning it wasn't successful, and we give it M, then what it would be N S. Okay, so on S we get a response time of a lot, and what I'm guessing is it would be a same name that we previously had. It's gonna be, we had SQLI free previously, if I remember. Yeah, SQLI free, so it's gonna be SQLI 4, and we are gonna just verify by the sleep timer SQ, and yeah, we are getting a 5-second delay response. So SQLI under 4, and let's see. So SQLI underscore 4 didn't got a valid result. SQLI, okay, so it was SQLI, okay, my bad. SQLI underscore 4, let's see this. Oh yeah, so this is the valid database name, and now we need to exploit it up. We need to enumerate more on this, and I did it on the back when I wasn't recording, and there is this particular payload that I used. So what it's doing is it's a referrer being used as admin123 initially, and then it's using the sleep function with the union operator to sleep for 5 seconds, and using the users table which we enumerated out using the same methodology using the sleep timer we did previously using the boolean as well, and then iterating over the usernames again and again till we get the successful ones, and on the admin we were able to get a sleep response of 5 seconds, and then we iterated it for like the characters that were associated with the username admin and password. On the percentage 4 I did got like a delay response of 5 seconds. What I am guessing completely, okay, so it's clear that we were able to produce a 5-second delay. On the 4-1, no delay. 4-2, it would be another number. 4-4, 4-5, 4-6, 4-7, 4-8, 4-9. Okay, so on 4-9 we were able, apparently I found out that we need to continue it again, and 49 is not the password. And on 492, 496, okay, so on 6 we are gonna get a delay, and I'm just gonna make the delay to 2 seconds so we can quickly evaluate our next number. 4960, 4961. Oh no, my keyboard really. 4961. Oh sorry, 4961, and we get a 2-second response. So 4961, let's try this. And yeah, with that we completed our this exercise as well. And if you are really not into trying this one by one, which I did, you can just use a Python script as well using ChatGPT to manually iterate it again and again for the numbers. And we completed our task number 8 as well. Now on to the task number 9, which is out of band SQL, which isn't as common as it either depends on specific features being enabled on the database server or the web application business logic, and it makes some kind of essential external network call based on the SQL query. And out of band SQL is classified generally by having two different communication channels, one to launch the attack and the other to gather the results. So the attack channel could be a web request, and the gathering channel could be a monitoring HTTP DNS request being made to the server. So an attacker makes a request to the website vulnerable to SQL injection first, and the website makes an SQL query to their database, which also passes the hacker's payload, and the payload contains a request which forces an HTTP request being made. So here the attacker, we generally request a website vulnerable to the SQL injection, and the website makes an SQL query here to the database, and which also passes through the hacker. And this we basically sitting between can be manipulate this and name a protocol beginning with D that can be used to exfiltrate data from the database. That would be DNS, if I'm not wrong, DNS. And we completed our task number 9 as well. And at last, there are some preventions we can use as developers for preventing SQL injection, which could be input validation, escaping user input prevention, and prepare statements. And generally these are best practices when writing the code. And name a method of protecting yourself from SQL injection exploit. So I don't know what it wants. Let's take a hint. P and okay, prepared statements, that would be answer. And with that we completed our room. I hope you enjoyed it. If you have any doubts, do leave a comment below. I will make sure to reply to it. And do give a like, do give a subscribe if you enjoyed. If anything that helped, make sure to leave a nice comment, and thanks for watching.